What's up guys, welcome to another video. This is Massey. In this video I want to show you how to evaluate limits using epsilon delta definition. First example, we have limit of x plus 2 when x is approaching 4. We know when we have x plus 2 and x is approaching 4, the limit is going to be 4 plus 2 and that's equal to 6. If we assume that there is a epsilon greater than 0, f of x minus L has to be less than epsilon, which means that x plus 2 minus 6, this is L, less than epsilon, which will be x minus 4 less than epsilon, which is going to be the same as delta because we have x approaching 0. So in this case, epsilon equals to delta. So let delta equals to epsilon. So if x minus 4 is between 0 and delta, which is going to be equal to epsilon, the absolute value of x minus 4 is less than infinity, then x plus 2 minus 6 is going to be less than epsilon, not infinity epsilon. And then we can say that f of x minus L is less than epsilon. Next example. Limit of 4x plus 5 when x is approaching negative 2. When you want to evaluate it, 4 times negative 2 plus 5, that's going to be negative 8 plus 5, that's going to be negative 3. Given epsilon greater than 0, we have 4x plus 5 minus negative 3, that has to be less than epsilon. So that will be 4x plus 8 less than epsilon. Then you factor 4. Take it out. Which means that delta has to be equal to epsilon over 4 in order to have a limit. So when delta equals to epsilon over 4, we can say that the limit exists. Why? Because we can say that when the absolute value of x plus 2, when it's between 0 and delta, which is equal to epsilon over 4, we can say that 4x plus 8 is going to be less than epsilon. And then we can say that 4x plus 5 minus negative 3 is going to be less than epsilon. And finally, f of x minus L is going to be less than epsilon. Next example. Limit of 1 over 2x minus 1 when x is approaching negative 4. You have 1 over 2 times negative 4 minus 1 is going to be negative 2 and negative 1 is going to be negative 3. Given epsilon greater than 0, we have f of x minus L has to be less than epsilon. F of x is 1 over 2x minus 1 minus negative 3. So that's going to be 1 over 2x plus 2 less than epsilon. So then you factor 1 over 2 and take it out, is going to be x plus 4 less than epsilon. Which means that absolute value of x plus 4 has to be less than 2 epsilon. So delta has to be equal to 2 epsilon in order to have this limit exists. Next example, limit of 3 over 4x plus 1 when x is approaching 3 is going to be 3 over 4 times 3 plus 1. That's going to be 9 over 4 plus 1, which is going to be 13 over 4. Then I can say f of x minus L has to be less than a positive value. So 3 over 4x plus 1 has to be less than 13 over 4 less than epsilon. Then 1 minus 13 over 4 is going to be 3 over 4x minus 9 over 4 less than epsilon. You take 3 over 4 out, x minus 3 less than epsilon. So x minus 3 is going to be 4 epsilon over 3. So delta is 4 epsilon over 3. Next one is limit of 3 when x is approaching 6 equals to 3. So you can say that f of x minus L has to be less than epsilon. So 3 minus 3 has to be less than epsilon. 3 minus 3 is 0, and 0 is less than epsilon. So for any delta, positive delta, that's gonna work. Next one. Limit of negative 1 when x is approaching 2 equals to negative 1. So f of x minus L equals to negative 1 minus negative 1 less than epsilon, which is 0 less than epsilon. Next example is limit of absolute value of x minus 5 when x is approaching negative 5 is going to be absolute value of negative 5 minus 5, which is going to be absolute value of negative 10. That's going to be positive 10. Then you can say that x minus 5 minus 10 is going to be less than epsilon. So that will be x since x is negative, because it is close to negative 5, the absolute value of x minus 5 is going to be negative of that. It's going to be negative x minus 5, because the function by itself is absolute value of x minus 5. So we need to put it in the absolute value. So it's going to be negative x minus 5 minus 10 less than epsilon. So that will be negative x minus 5 less than epsilon, because negative times negative is going to be positive. Positive 5 and negative 10 is going to be negative 5. Then you can say negative absolute value of negative x minus 5 is less than epsilon. So that's going to be x plus 5 less than epsilon. So in this case, epsilon is going to be equal to delta. Next example is going to be limit of absolute value of x minus 3 when x is approaching 3. You know, it's going to be 3 minus 3 is going to be equal to 0. Then you can say that absolute value of x minus 3 minus 0 has to be less than epsilon, which will be x minus 3 less than epsilon. So again, as you see here, epsilon is going to be equal to delta. Next one, limit of x squared plus 1 when x is approaching 1 is going to be 1 plus 1, and that's going to be equal to 2. So x squared plus 1 minus 2 less than epsilon. So it's going to be x squared minus 1 less than epsilon. So we can factor that. It's epsilon. So therefore, we keep the x minus 1, epsilon over absolute value of x plus 1. So if we assume that x is between 0 and 2, because that's around 1, 0 and 2, we can say that delta is epsilon over 3. Next example, limit of x squared plus 4x when x is approaching -4, it's going to be -4 squared plus 4 times -4. That's going to be 16 minus 16 equals to 0. So that will be x squared plus 4x minus 0 has to be less than epsilon. Then you factor that. This will be less than epsilon. So x plus 4 has to be epsilon over x. And then you can say that if you assume x is between -5 and -3, then you can say that delta is epsilon over 5. So that's how you find out the limit and delta. I hope you enjoyed this video. Please don't forget to subscribe this channel. You can have access to many other videos regarding limits, differentiation, integral, and other topics in calculus, physics, and chemistry. Thank you for watching and have a great day.